What's up, party people? My name is Sunny Ray. This is the Sunny Ray Show. We're back at it again. A full day of awesome interviews. I had a gentleman that I was just speaking with this morning for a pre-interview, but I was so impressed with what he's building that I thought, why wait a couple weeks? Let's bring him on. His name is Moti Margalit. He's the co-founder and CEO of SonicEdge, an Israeli deep tech company rethinking how a speaker works at the physical level. I'm going to bring him on right now. His name is Moti. How are you doing, sir?
I'm good, thanks. How are you?
I'm great. So you're building speakers for these new glasses that are coming out. Is that correct?
Well, we're building speakers for many applications. One of them is for the glasses. We like to say that AI needs a voice, and we're supplying the speaker to make it happen.
Wow. Wow. I mean, I very, very bullish on glasses in general. Obviously, seems to be where the puck is moving. Moti, what is SonicEdge? What are you building and why should people care?
Okay, sure. So if you look at the world of speakers, really not much has changed in the last 150 years since they were invented. Basically, a moving membrane moves, pushes air, and generates what we perceive as sound. When you try to shrink that down, you pay in sound quality. So the result is that there hasn't been a good small speaker. When we started SonicEdge, we went back to first principles and asked ourselves, what can we do with a really small speaker? If you look at your home, you'll see a subwoofer is a large speaker, but it generates low frequencies. A tweeter is much smaller, it generates high frequencies. So to make a really small speaker, something the width of a hair, it's good at making ultrasound. Our speakers vibrate at 400,000 times a second and generate great ultrasound. The problem is we're not bats, we can't enjoy that music. So we need somehow to take that ultrasound and make it into sound. And this was really the breakthrough of our technology, that we transform ultrasound into sound through active modulation. Basically, our structure is a couple of membranes that both generate ultrasound and then modulate it to generate sound from the ultrasound. The result is a very compact speaker with superior audio performance that can be used in earphones, smart glasses, cell phones, basically everywhere you have today an existing speaker. We can do to sound a bit like what LEDs have done to lighting. We start with the flashlights and then extend to everywhere.
Wow. Wow. So your research background is in quantum optics and photonics. What actually connects that world to LEDs and now acoustics?
So that's actually a very convoluted path. Like you said, my background originally ultra-fast lasers, and then I did research at MIT in quantum optics. Came back to Israel, and then I started working in silicon photonics. So today, that's also a very popular field, and we commercialized and invented some key concepts in silicon photonics back in 2000. That led to a lot of experience in both MEMS and packaging of electronics. So for the next, let's not count the years, but for quite a few years, I was doing both commercial activity, research activity, and development in the field of components. And that was both MEMS, electro-optic components, packaging of electronics, and combining everything into systems. The LEDs came out because one of the things that I developed about 15 years ago was a very smart way of packaging LEDs. And as a result, I built a company around that, making a very low-cost process to package LEDs. Later on, I also applied my expertise in MEMS and now acoustics to SonicEdge to develop these new type of speakers.
That is so amazing and so interesting and cool. And so relevant, right? I mean, people like me we've got headphones on all day. I mean, my wife does, the kiddies do. I mean, it's such a big deal. So you need earbud and hearing aid makers to redesign around your chip instead of a standard. So how does that sales conversation start?
So the sales conversation starts with, of course, you can't make us, I'm talking a few years ago, they would say, yes, people have tried selling us these small speakers, they never work. And then we would say, but ours is different. We actually invented a new physical principle to make this work. And the first time they would measure them in their labs, they were amazed that we could actually supply such a good base and other performance. They were amazed at what we can do it from the small size. When we explained the physics, the first reaction was, wow, that's so simple. And then, of course, they would matter, why did I think of that? So, that's really the classical inventions that are just waiting to be developed, but they do need to combine multiple disciplines into a technology. So we basically invented this from scratch, and over the years, we've pushed this technology both in performance as well as in terms of understanding the basics of it. In terms of how the sales discussion goes, so we start from the R&D people, where we convince them the viability and the advantages of our technology. And then after some POCs and the discussions, they have enough confidence to suggest us to the product people. The product people are the ones that actually make decisions on what goes into the products. This is both a combination of design, user experience, practical aspects like manufacturing, reliability. All those go into the product decision. The combination of that is a design cycle where a product team would design a product using or built around our components. In the earphone space, that is typically 12 months or so from a start to a design win and basically launching a product in the market. And that is when we can start generating sales. So we have developed something totally new. We need to build the confidence in the company that this is a viable route forward. And once we have those champions in place, they push us to the product people to include this into the product roadmap. Semiconductor companies, electronic companies have very rigid and long roadmaps. They know, like Apple or others would know 5 years into the future what they're doing. But then sometimes when a technology that is disruptive like us comes and solves some very big problems they have, sometimes they would change those. It depends on the company.
Fascinating. So Moti, what did you know starting SonicEdge, your fifth company, that you didn't know on your first?
So I think, first of all, one thing you learn is that you'll always be surprised. The things that have hit you before, those you know to avoid, but there'll be new things that are unexpected. We actually, when we started the company, COVID hit. That was an example of a totally unexpected phenomena. But also other aspects come out. I think the important thing that I came to SonicEdge was to talk with customers from the very beginning. That means, I think 3 months out, when we just had a very provisional proof of concept, and we could play some tones, we were out across the world talking with customers and trying to understand what are the problems and how we might be able to solve them with this technology. So that was really a key lesson, and it's a non-obvious lesson, because when you do deep tech, it takes a long time by definition from when you have an idea until you can actually go and have a discussion with customers around prototypes or around something that's tangible. I mean, you don't go to a customer with a PowerPoint and try to pitch a crazy idea. No one will believe it will actually work. So what we coming into this company, we were very focused on being able to demonstrate the concepts that we were pushing immediately with very little funding, talking to customers and building up the confidence that what we're doing is important enough so we can dive into the deep tech. We can take the years that are required to develop a new technology and then bring it to market.
Wow. So, and Moti, with over like 100 patents, is there one you're most like proud of that most people have not heard of?
Well, SonicEdge, but people
SonicEdge. Okay, understandable. Cool. So,
yeah.
I was gonna say, so Ari's hearing aid sounded bad even as the technology improves. Can you walk me through that actual conversation?
So I think this is a common problem to anyone using hearing aids. Hearing aids need a really small speaker. The speaker of choice there is a balanced armature because it's small enough to fit into the ear canal. But the problem is the balanced armature has a relatively limited bandwidth. It's really geared around where voice is strong. So it enhances speech. It's better than nothing, but it does not have the high frequencies which enable us to distinguish the location of sounds, to enjoy music. It does not have the very low frequencies, which a major part of the sound and voice and music also exists. So the result is that anyone using a hearing aid says, again, it's better than nothing, but it complains that they can't enjoy music. They get lost once there is noise, or in a large crowd, they can't make out what people are talking, and there's no noise cancellation because you don't have the low frequencies. So this is, I am not, 15 years ago, I was not using hearing aids. I did not know these problems, and my partner Ari was. So from that discussion, suddenly I understood that this solution that so many people are relying on is actually a cause for complaint. And the statistics talk about 50% of the users that stop using them out of frustration within 1 year. So the hearing aid situation is certainly the trigger for this, but then we shifted focus to the more consumer-oriented applications, because as we started speaking with the earphone and other manufacturers, we realized they were really constrained by the size of the speakers. I mean, the whole earphones, they all look the same because they're driving the same speakers, which are connected to the ear in the same way. You can't make them much smaller, you can't make them much more comfortable because of the basic acoustic limitations. And that's why we quickly gravitated to earphones, because that's an immediate market with a very big requirement on reducing size and increasing the comfort.
And once you decided to rethink the speaker, where did you start? Like, what does a traditional speaker get wrong? I think you talked about the key, like just the form factor, but like, can you go deeper into it? Like, what are you doing inside this this device that's making it so remarkable?
Sure, that's an excellent question. A standard speaker is built of a membrane and some motor. So the motor pushes the membrane back and forth. That pushes air, generates pressure waves, which travel through air, reach our ears, and generate sound for us. So basically, you still need to generate these pressure waves, but you need a, I would say, more efficient mechanism of doing it. We started with the concept of modulated ultrasound, and to be honest, when I started, I was coming from electro-optics, packaging, MEMS, but I did not really understand acoustics. And the acoustic people were challenging me, saying, okay, we see it work, but please explain it to us, because at the end of the day, a speaker pushes air. And your very small speaker is pushing a very small amount of air. So how can it generate the same sound like a loud speaker? It took us another year or so to understand that the physics of our structure is actually the physics of a pump. Our device, which is the width of a hair, but we have several hundred of these, is essentially a very high-speed air pump. It's working 400,000 times a second, pushing out these very small pulses of air. However, if you compare that to, let's say, a standard speaker working 1,000 times a second, generating something in the audio band, it's pushing air and it's pulling it back. In the time that a loudspeaker moves once, our speaker moves 400 times. So we are replacing the size of the speaker with the speed of the pump. We're moving the same amount of air, but instead of doing it with a loudspeaker, we're doing it with a very small pump, working very quickly. The analogy to that is Dyson. If you look before Dyson, the vacuums were large and cumbersome. The innovation behind the Dyson vacuum is that instead of using a slow pump, he uses a very fast pump. The result is it can make the pump much smaller because it's moving the same amount of air, but it's doing so by speed rather than size. It's more efficient. You could start using batteries instead of a cord, and it gives them some additional benefits in terms of the structure around it. So the movement from size to speed is something that is done, but has never been done in acoustics because no one had this very novel idea of an air pump that can function as a speaker.
Crazy. So what's the hardest technical problem between the idea and a working prototype?
So we make this speaker in a technology called MEMS, micro electromechanical systems, basically carving out in silicon mechanical structures. This field was invented in the 80s, and the initial products were inkjet heads and accelerometers. And today, many of the sensors, or all the sensors in, for example, your cell phone, is built around these MEMS devices, accelerometers, gyros, barometers. All these are done using mechanical structures fabricated in silicon. Our speakers are made in the same way, in the same manufacturing plants that make all these kinds of sensors. This process is, I would say, less standard than a semiconductor process. In electronics, you make a design, what you design is typically very close to what you actually get back from the fab. In MEMS, there is a larger deviation, there is more flexibility in how you define the process. As a result, there is more work for us on making the architecture, making the flow, and working with the production fab to make this work in a way that can be scalable and low cost enough. So there are multiple challenges in having a concept through the building up the simulations and physical understanding to actually fabricating this and being able to deploy this in mass volume.
Interesting. And so, and you know, Moti, the Sonic Twin is 8 by 4 by 1 millimeters, right? With a full 20 hertz to 20 kilohertz range. What does that unlock that today's earbuds can't?
So the Sonic Twin is one of our products. Our Sonic Core products, SC100, SC200, those are just speakers, and they replace existing speakers, providing better sound in a smaller form factor. The Sonic Twin is one step beyond that. It combines both a speaker and a microphone in the same package. And that is actually super crucial because as we shrink the speaker and we want everything to fit into the ear, our customers are facing challenges of having the feedback microphone combined with the speaker. We provide them with one package, and the reason that we can do it and others can't is that our speakers are basically working in the ultrasound. They're essentially pushing air. As a result, there are no mechanical vibrations. There's no electrical or mechanical crosstalk between our speakers and a microphone. We can put them really close together and get great feedback for superior noise cancellation. So our Sonic core products enable a smaller speaker. The Sonic Twin takes it one step further and enables combining additional sensors in the same speaker package, enabled by the fact that we have no vibrations and no electrical crosstalk.
Wow. And Moti, if smart glasses become as important as smartphones, why does the speaker matter that much?
So the speaker in smart glasses is actually a critical component. It's both form factor and weight. Both need to go down to make smart glasses comfortable and appealing to consumers. So that is why we see a lot of interest in our products in the smart glass space. You mentioned cell phones. It's an open question if they will replace or live one by side by side. But also, if you look at the cell phones, there's also always pressure at cell phones to make the components thinner. For example, the Airphone, when it came out, it gave up on one speaker because it didn't have room to put it in. And if you look at all the foldable phones, thickness is becoming really a problem. So in all of these applications, even in cell phones, even if the glasses don't take off, cell phones still need very thin speakers where our speakers can shine.
What an invention. So, deep tech hardware fundraising means proving the physics works before there's a product, right? So what did investors need to see?
So at each stage of the company's life, investors need to see different things. Initially, they were seeing the proof of concept that we did using off-the-shelf components. So they understood the physics is there, but then the question was about, can we make it really small in MEMS technology? Then, as we started working in MEMS technology, the initial prototypes were, of course, not performing very well, and the investors needed a leap of faith that we can take something that today is maybe 100 times worse than what customers are hoping for and bring it up to the customer expectations. So that is where most of the funding came at different stages. And as we were closer to reaching our goal and we got the POCs with customers, the risk or perception of the investors changed over time until today, where we are actively working with a few customers on both POCs and some NRE projects. The investors have both the confidence that we can take this to market, and that there is a market that has an interest in these products. I mean, the big problem for deep tech companies is that in software, when you look at a round company, typically you have market validation through some ARR metric or some other hard cash coming into the company saying, okay, we have the customer validation, we have the market validation, now it's just about scaling this up. In deep tech, that is more difficult, and just scaling it up is also challenging and capital intensive. So in deep tech, the conversations are a bit different, and the market validation is more nuanced. But that is why some investors specialize in deep tech, and they understand these market dynamics, they understand the time it takes to mature deep tech technologies, but also the hockey stick associated with them, that once you break through, and there are numerous examples in the market where very small components are really generating a lot of revenue and very profitable because of the challenges in making them happen.
And Moti, you were nominated for International Entrepreneur of the Year 2026. What does SonicEdge need to prove in the next 2 years?
I think we need to prove that we can scale this to a very high volume. Of course, we need the customers to make that happen, but we are beyond the technical risk. and it's now taking this on the one hand into production, and on the other hand working with the customers in design cycles towards the integration of this into products.
Awesome. Moti, where do people learn more about Sonic Edge, or your company, and also about yourself if they want to learn?
So first of all, LinkedIn is an excellent resource. We also have quite a few videos, white papers, and other stuff on our website. And we've also published two technical articles. They are a bit technical, peer-reviewed technical articles. But for someone who wants to have a deeper dive into the technology, and they can, Google my name and they'll see these articles come up. And I think those articles do a good job about really explaining the physics, beyond the hand waving that we did earlier today.
Okay, well, thank you so much. You've been a delightful guest. Well, what
Thank you.
a huge technology you're building and pioneering. So, Moti, hang out for 1 minute. I'm going to bring this stream to an end. I see we have quite a few people listening live as well. So thank you all as usual for tuning in. I'll have another interview in about 15 minutes. Stay tuned. And yeah, Moti, just hang out for 1 bit. Cheers, everyone. Bye-bye.